Fourth grade lesson 7.8 is now subtraction with renaming. So we may get into this borrowing situation that we need to do when we subtract. And so this lesson is going to show you how to do that. The essential question is, how can you rename a mixed number to help you subtract? Ramon, Chandler, and Chase go bike riding on weekends. On one weekend, Chase rode his bike for 3 hours. Chandler rode her bike for 2 1/4 of an hour, and Ramon rode his bike for 1 3/4 of an hour. How much longer did Chandler ride her bike than Ramon did? Well, by now you guys know how much longer means, how much longer is a subtract sort of a question. We're looking for the difference between two. So what operation will I use? I will subtract. How much more or how much less is a difference problem, and that is subtract. They gave us 3 people's worth of distances, but when they asked us, they only asked us about the comparison between Chandler and Ramon. So we're only going to focus on Chandler, who rode 2 1/4 mile, and Ramon, who rode for 1 3/4 an hour. Chandler rode 2 1/4 hours, and Ramon rode for 1 3/4 hours. And I did not circle Chase's hours because it didn't matter. It wasn't asked of us. So we really only need to know the 2 1/4 and subtract from it the 1 3/4. So at first they have us go ahead and start out by modeling this out so our brains can see it. Shade the model to show how long Chandler rode her bike, and then shade the model to show how long Ramon rode his bike. So 2 whole and 1/4 for Chandler is going to shade like this. We'll go 1 whole, then 2 whole, and then 1/4 right there. All of that gets shaded. Pretend I stayed in the lines. And then for Ramon, his was 1 3/4, so we will do 1 shaded in this green color. That's hard to see. How about this instead? That's better. 1 whole, and then 1/4, 2/4, 3/4. Okay. When I do this visually, I can see that the difference between them to get from here to here is 2/4. 2/4. So Chandler rode her bike 2/4 hour longer than Ramon did. This question here says because if we weren't going to draw it, if we were going to calculate it, this is what it would have looked like. But if you have 1/4 size part, can you take away 3/4 size parts? If you have 1/4 size part, can you take away 3/4 size part? Think about when regular subtraction. If I have $1, can you take 3 away from me? No, right? So if you have 1/4 part, somebody can't take 3/4 part away. You can't take 3/4 part away from that. There's not enough. However, if I have 1 whole and 1/4 size part, then can I take 3/4 part away? So what they're asking us here is, if I have 1 whole and 1/4, is there enough for me to take 3/4 away? And let's look at that in a picture form. 1 whole pie, not cut up yet. Better not cut that up, Mrs. Sanchez, not yet. And 1/4 of another pie. So this is how much we have, is this whole part and 1/4 of it. Is there enough for me to take 3/4 away? Well, there is. I just need to go ahead and cut up this pie, because then once I do that, I have 1, 2, 3, 4, 5/4, right? That is now 5/4, and that's plenty in order to take 3/4 away. 5 minus 3 is 2/4, right? So if I have 1 whole and 1/4 size, is there enough to take 3/4 away? Yes. I need to cut the whole one. That's what I need to do in order to be able to do that. So when I mentioned that you could do subtraction of mixed numbers with borrowing, that's where we're going towards. And this part is going to show us how to do that. We want to find the difference between 5 and 1/8 minus 3 and 3/8. And just because we've been writing it in this way in the previous lessons, better color, 5 and 1/8 minus 3 and 3/8. I'm going to write it vertically instead of horizontally here. Here they say, think about 5 and 1/8 as, well, and I'm going to, before I even get to that, I'm going to make sure that we get to the point where we notice that we have to deal with this. If we don't need to deal with this, then we don't deal with this. But here we go. Remember in the previous lesson, we always started with our fractions. So we're going to take a look, and we have 1/8, and we want to take 3/8 away from that. Well, if I have 1/8, you can't take 3/8 away from that. So yes, okay, now I run into the issue that I need to borrow. So they said, I really only need one of these pies that are uncut. There's 5 uncut ones. I really only need one uncut. So they said, think about this 5 as 4 plus 1. We'll take 1 and set it aside, right? 4 plus 1 is 5, and we still have the 1/8 there. And we're going to take this 1 and turn it into the full fraction, 8/8, because that's still the whole thing. We just went ahead and cut it up so that we're ready to pull it apart. Then we're going to put these two together. We're going to add these two amounts together, 8/8 plus 1/8. We still have the 4 whole pieces from right here, and now we have 9/8. So we did that, and I'll write it over here. So now we have 4 and 9/8 because we took one of these and put it into 8/8 and added the 8/8 to this 1/8. One of those is gone. And then we added 8 to the 8/8 and got 9/8. That's our borrowing. And now that we've borrowed, there's plenty for us to do the subtraction from here. 9/8 minus 3/8 is 6/8, and 4 minus 3 is 1. So they have us now, this is what they're doing here. Instead of 5 and 1/8, we're going to use 4 and 9/8. 9/8 minus 3/8 is 6/8, and 4 minus 3 is 1. That's one way you can do it. And in my opinion, it's the easier way, only at first it takes a lot of practice to get your head wrapped around it and get used to it. But once you get used to that, this is an easier way. You're dealing with smaller numbers than you will if you choose this way. This is fine. This is a good method to do it, and it will work. You're just going to end up dealing with larger numbers. So here is the other option. We can just rename both of the mixed numbers into improper fractions like we learned in the previous lesson. So we have 3 wholes and 4 twelfths. Well, 3 wholes with a denominator of 12 is going to be 12 twelfths, a better color. 12 twelfths is 1, plus 12 twelfths is 2, plus 12 twelfths is 3, plus 4 twelfths, right? And I had mentioned in the last lesson, because we have 1, 2, 3 times 12, 3 times 12, and then add the 4. So that 12 plus 12 plus 12 is 36, 37, 38, 39, 40 twelfths is the rename as an improper fraction. Then we have 1 times 12 is 12, plus 6 more is 18. I will show that visually in case you need to see it. I'm doing this 1 cut into 12 pieces, so it's 12 twelfths, plus, this is equivalent to 1, right? Plus this 6 twelfths equals 18 twelfths. Okay. And now that I have them set up as improper fractions, I'm going to write them that way. And now I just have to do subtraction like I've normally been doing. We know our denominator is going to come out as a 12. And we just need to do 40 minus 18 now. Well, this one does require that I do a little bit of borrowing anyway. 10 minus 8 is 2. 3 minus 1 is 2. And that is 22 twelfths is the answer. I can change that back into a mixed number. 12 goes into 22 once with 10 twelfths left over. And there's your final answer. So that's another choice you could do, is just because you do get pretty fast at converting mixed numbers into improper fractions and converting them back again, especially as you get into those upper grades. When we're multiplying with fractions, we're going to have to do that, or with mixed numbers, we're going to have to do that anyway. So that is a good option. You can go that route when you're subtracting. It's good practice to get into. So it just means that you're dealing with larger numbers here. Here we got to deal with some smaller numbers because we only uncut one of them instead of uncutting all of them, or cutting, I guess. We only cut one of them here instead of cutting all of them here. This question at the bottom of that page says, explain how you can rename the whole number 5 to subtract 3 1/4. So what if I start with a whole number with no fraction and I have to subtract 3 1/4? Remember, subtraction is not commutative. I can't flip things around and go in whichever order I want. Addition is, multiplication is, but subtraction is not. And if I don't have a fractional amount to subtract here, there's nothing to take away. So I need to create this fractional amount. We're going to look at this as a 4 plus 1 is 5, right? And then we're going to take that 1 and we're going to cut it into fourths because I would like to keep that same denominator. So we'll cut it into 4 pieces, and that's going to become 4 fourths. So now my new denominator, or not my new denominator, my new mixed number is 4 4/4 because I took one of those and I cut it into 4 equal pieces. Now I'm good to go. I can do 4 fourths minus 1/4, that is 3 fourths, and 4 minus 3 is 1. So explain how you could rename 5 to subtract 3 1/4. I can change it to 4 4/4 because 4 plus that one more 4/4 is still 5. It's just that now I've cut one of those pizzas up. Okay, this is certainly going to take some practice. It's not, if you're feeling like, oh, this seems kind of hard. Yeah, it is at first, but you'll get it definitely. Okay, so we're going to rename both mixed numbers as fractions and find the difference. So this was just changing them completely over. That trick of 3, if you do this number times this one, and then add that one, it becomes your new numerator. I'll multiply that, add that to it, make it your numerator. That works only because what we're saying is I'm taking that 3 whole pizzas and I'm cutting it into 6 6 for one of them, 6 6 for another one, 6 6 for another one, and that's 3 of them. And then I have the 3 6 that are left. So I'm basically doing 6 3 times, 6 3 times, 6 times 3. That is 18, 19, 20, 21. 6, 12, 18, 19, 20, 21, 21, 6. For this one, we would do 1 times 6 is 6, plus 4, 7, 8, 9, 10 for our new numerator. Here it is visually. I'm cutting this into 6 pieces. That's going to be 6 sixths, plus the 4 6 that are already there equals 10 6. There was only 1 6 there, 1 6. Add the 4 that are there. I can get 10 6. Now I'll subtract 21 minus 10 is 11. And there's my answer. If you want it as a mixed number, we divide those. 6 goes into 11 once. 1 times 6 is 6. I end up with 5 left over, 5 out of the 6. So 1 and 5 6 is the same as 11 6, same amount, just uncutting the 6 6 that were in there. All right, what about if we wanted to borrow it? So there was that one option, right? The option of just 3 times 6 is 18, 19, 20, 21, done. 1 times 6 is 6, 7, 8, 9, 10, done. And then subtracting it. And you'll get really good at doing that over time. But that was one option. The other option is just to borrow the one piece that we need and not all of those numbers. So I have 1 1/3 minus 2/3. 1/3. I can't take 2/3 away from that. I don't have enough. So I'm going to break that 1 into 3/3. And I still have the 1/3 there. That makes 4/3 now. Now I have enough to take the 2/3 away. 4 minus 2 is 2. Let's look at the next one. We have 4 and 7/10 minus 1 and 9/10. If I have 7/10, I don't have enough to take 9/10 away from that. Fine, that's okay. This is 4, and I'm gonna pull one of those away. So there's 4 whole pizzas, right? I'm gonna take one of those whole pizzas. So now I only have 3 whole pizzas, and I'm going to cut it into 10 equal slices because all these other ones are cut into tenths. So I'm going to still have 10/10. That 1 that I pulled off of here is now here. 7 plus 10 is 17/10. And now I can take 9/10 away from that. 17 minus 9 is 8. So I ended up with 8/10 after borrowing. And then I do the whole numbers 3 now instead of 4 because I took 1, put it there. 3 minus 1 is 2. And there's my answer. With practice that becomes easier, but if you feel like I totally get this one, and yes, I get that they're bigger numbers, but I can deal with that, then stick with that. You're welcome to stick with that. If this makes sense, then, or starting to make sense, I should say, then you could use that too. It's whichever you prefer. Both will work. We have 3 and 5/12, subtract 8/12. 5/12 minus 8/12 is not going to work. If I only have 5, you can't take 8 from me. So I need to come over here and take one of those 3 whole pizzas. Now I'll only have 2, and I'm going to cut that one pizza into 12 pieces. I'm doing 12 pieces because that's what my denominators are. Add that to those 5/12 that were there already. That gives me 17/12, which gives me plenty for that 8/12 to be subtracted from. 17 minus 8 is 9. And then I still had these 2 minus no whole numbers, so 2 is still there. So my answer, 2 and 9/12. If you're feeling like you get this, you can go ahead and go. Just remember with the word problems that you might see, remember anytime you're looking for the difference, if somebody did more of something, or you want to know how much more did they do or how much less did they do, just remember your subtraction language. You're welcome to go to Think Central and show that you get it. If you feel like you need a few more, I'll do a few more with you just to help you make sure you solidify your knowledge. Okay, I have 8 and 1/10, and I'm subtracting from it 2 and 9/10. Start with the fractions. 1/10 minus 9/10. If I only have 1/10 to start with, I can't take 9/10 away. It's not possible. So I'll go to this neighbor over here, the 8 pizzas that are sitting there, not cut. I'm going to take one of them, so I'll have 7 left. I'm going to cut that into tenths because that's my denominator. And this is the one that I took from here, and I cut it up. And now I have 11/10. 1 plus 10 is 11/10. And then I can take the 9/10 away from that. Now I can do it, right? 11 minus 9 is 2. So I end up getting 2/10. And then I just take the rest of the uncut pizzas. 7 minus 2 is 5. Let's take a look at this one. I have 2 whole, and I'm subtracting 1 and 1/4. Well, remember we start with our fractions, and I don't have any fraction there. Not a fraction to be seen. I can make one, though, and I need to make one. So I'm going to go ahead and take these 2 pizzas that are not cut up, take one of them, so now I'll only have 1 left. I'm going to cut it into fourths because that's the denominator I'm dealing with. Let's keep these numbers easy, right? So I still have the 4/4 there. This is 1, and this is 1 more for a total of 2. But now I have the fraction I need to subtract. 4/4 minus 1/4 is 3/4. And 1 minus 1 is 0, so I can leave the 0 off there. I don't have to put it there. One more. I think you're maybe feeling like you're getting a little closer. We can continue after this in class if it's still needed, but hopefully you're feeling like it's coming along. We have 4 and 1/5 minus 3 and 2/5. 1/5 minus 2/5. If I only have 1/5, you can't take 2/5 from me. So I will borrow from the 4, and there will only be 3 now. And I will cut that up into 5 pieces since that's the denominator size I'm looking at. That gives me 6/5 now. I can take 2/5 from 6/5, no problem. 6 minus 2 is 4. So my fractions end up being 4/5. And now I look at my whole numbers. 3 minus 3 is 0. So I don't have to write anything there. If it's 0, it's nothing. Nothing is nothing. I can put the 0, but you don't need to. I hope those last 3 helped you guys out. Hopefully that works for you and you're ready to go to Think Central. If you're not, please let me know so I can go over more with you in class.